Hi, everybody. If you don't know me, my name is Rohan. Okay, most of you do actually know me. Some of you work with me. Welcome to DevHub. This is a place that I started my talking journey. This used to be my desk when I had my startup here. I used to be an instructor here. Actually, let's go into this slide. That's me. If the lights went off, and actually somebody want to get the lights from me? You know where they are? They're right there. Hey, my beard is right here. That's a picture of my beard. But there's some other interesting tidbits in here. Zach, look left. Right there in front of you. Yeah. See, I actually know this space. I used to teach here. There you go, look at that. Okay, cool. So my name is Rohan. If you're ever on Toronto.js, that's my avatar. That's also my title. I make fun of Tease. Can Tease put his hand up? Thank you. So, quick story. Tyler over there, he comes to lots of my talks. And he always likes to heckle me, but today he can't because he doesn't know enough Elixir. So let's all give him a round of applause for showing up and shutting up for the first time in a while. So my current job is Senior Technology Director at Highline Beta. I get paid to build companies. The Senior Technology Director part, it's all smoke and mirrors to say that my job is to actually do lots of architecture and a lot of exposition to figure out where ventures can actually be built. Previously, I was the first speaker at Polyhack, so shouts out to Adam and Zach's got his hand up already, ready to go. But I was the first speaker here. I'm a frequent contributor at Toronto.js. If you've ever been in there, you know I'm trolling. Head of engineering, Pungo Payments. Pungo's actually on the other side, but they're not here right now. Stosh, who some of you know, should be on this side, but he's not paying attention. I founded a company called Quartermaster. That's where my desk was. That whiteboard was put up for me. Before that, I've been an instructor here. We've talked about this. Product development lead, Terapeakers, shout out. Yay. Thanks, Masashi. The other two have decided to not even participate in this. They're right there. Before that, I was at Well.ca. I was also in a bunch of other shitty places in the middle of that don't bear putting on my slide. So, really quick thing, Highline Beta, we build companies with big corporate clients. We are hiring a role, full stack developer, React, Redux, Node. It's actually really, really interesting. I can't talk too much about it, but come talk to me when I have a couple beers in me, which is already passed, and I'll tell you a little bit more. But like if you're actually looking for a new role, down here, the only person here who won't be hired for that role is Tyler. He's got to put smaller PRs in. Okay, so my talk today is Elixir and OTP. My talk is not nearly as deep as either Jordan or Leo's. They actually know way more than me, and they have taught me a lot of stuff. So you know how much of them I'm going to do a talk about something they don't know, which is Elixir. What is Elixir? Elixir is this awesome functional language which compiles and runs in the Erlang runtime. Has anybody here actually used Elixir before? Like literally nobody? Okay, thank you. I'm disappointed in some of you. It looks like Ruby, but it's not Ruby. That's a good thing. Networking aspect is like Kubernetes, and we're going to briefly touch on why that is. I built my last two startups on Elixir. Part of that was started off on Node, but I'm like super evangelist, super bullish on Elixir. I would try to use Elixir at any point in time in my life that I possibly could, except for compile to JavaScript. Thank you. But like to me, Elixir is a really interesting shift in how languages are going, and Erlang has a runtime that is 10 years older than the JVM. So it's like old, battle-tested, really awesome. WhatsApp runs on it. A bunch of other awesome companies are taking up Elixir. What is OTP? OTP, there used to be something that acronym meant. Really now OTP is just a bunch of set of libraries, a bit of runtime stuff, a lot of interesting things that are packed into the Elixir runtime, which is known as Beam. But the big part is the design principle aspect. And the design principle aspect is actually way bigger than most people understand. Who here has heard of like the actor model? Great. Who here has heard of Go's concurrency story? Great. Those are all implementations of what what Erlang's concurrency story actually looks like. And I mean, Great, like good for them. But Elixir now introduces an accessible way to get into this runtime, which to me makes it super, super powerful and also makes it extremely exciting. Another amazing part about Elixir is that on Hacker News, nobody said anything bad about Elixir ever. Like, it's the greatest thing. Like, Hacker News says bad shit about, like, candy. So, OTP is the networking layer of Erlang. OTP, basically, an interesting thing to understand about it, you're isolating processes, you're isolating state, and you're isolating runtime. And those things aren't isolated in a mutually exclusive way, but it's just isolated from each other. Things that we need to kind of touch on, because I'm introducing a whole new runtime here. A process is not like an OS process. A process is just an abstract way of referring to a specific, lightweight, easy to create and destroy thing. And within that thing, we run units of work. So in our case, units of work means functions. And this is a functional programming language, makes complete sense. And then there's this little interesting thing that's called a pipe operator. It just helps us pass a value from a preceding function or preceding unit of work to a subsequent unit of work. And this is just a light bit of syntax. For those of you who've seen other talks of me that I've given about Elixir, we're not going to go into any of the deep structures. We're not going to go into my favorite thing ever, which is pattern matching. We're just going to talk really, really lightly, really surface level about OTP and the concurrency model. So let's just jump into code. And I'm moving over here. So, yes, that's a bit. Thank you, guys. This is code. Tally, can you read that? OK, great. So this is Elixir. It looks kind of like Ruby. There's this awesome thing here called a do. This is what really differentiates it. We have here a full module. Elixir is functional. There's no OOP. So everything is going to look a little bit different than what you're expecting. But a module is basically how we organize units of code. And because this is a compiled language, we pull them together when we actually run the program. We have these cool things. They're known as functions. Some of you might have heard of functions. But I was previously talking about them. Spoilers. This is a function called startLink. Shocking, I know. And it's demarked by this def n block. And the Rubyists in the room will find this part weird, that do, right? But don't worry, it's all accessible, nothing will hurt you. Past that, we can do a bunch of different things. There's a couple other things I want to talk about really quickly. This is a data structure called a tuple. And a tuple is just basically a way of grouping a few different values together. And this weird thing in front of the word add, it's not a weird thing in the full sense of English, but that colon denotes that this is an atom. An atom is like a symbol. So what we have right here, what we have right here is a tag tuple, where the first value in that tuple is an actual symbol, and the second value is something. And that second value is actually a variable that we're assigning whatever comes out of this function to. All of this will make sense in a little bit. First, let's jump over here. So, Tali, can you read that? Did you say no before? Yes. Oh. OK, there. OK, much better. Here, let me do this too. OK, cool. That's Tali, that's Leo's wife. This is IEX. This is Elixir's REPL. It's not actually a REPL, but I'm not going to go into that today. Ask me about it later. In here, we can do cool things like writing integers, writing strings. This is a binary list. It's not actually a string. We can do some other interesting stuff with it. The basic point is this isn't scary yet, right? Nobody's scared? Jordan? We're good. So I'm going to run this really, really interesting thing. It's a process that I'm going to spin up. And I'm going to spin up this process, and I'm going to execute a little piece of code in it. And I'm not going to actually type this code out in front of you because I'm going to save you that pain. But I'm just going to run this bit of code. It's called spawn. Spawn is a function. that allows us to run whatever code's passed into it. So here I have spawn, and then I have a lambda that is outputting hello Polyhack. So for those of you who use Go, it's just basically the same as a Go routine. It's like, hey, go blah, 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 blah. Spawn is really interesting, though, because while I'm saying hello Polyhack here, it actually returns this weird thing. So there's another way that I could pull up a weird little moniker like that. I'm going to type in self. Oh, another PID. These PIDs refer to process IDs. So every single unit of work in the Elixir runtime runs within a process, and each of these processes has an actual address. These addresses are really, really important because this is what allows us to actually execute every single thing in the entire Erlang universe. And also these processes. And you don't have to memorize any of this, but just like start building a mental picture of a bunch of small little things, but they start connecting to one another. And they're all processes, and they're all named in weird ways. So maybe 0.113.0 and 0.118.0 have like 5 other processes or 4 other processes spun up in between all of them. Maybe. Right now it doesn't matter, but just have that mental model in there. So we're going to do something interesting right now. I'm going to take this entire line. And with this entire line, when I paste it in, same stuff happens. But when I look at PID, PID's got this same thing. Another interesting thing you might notice is 121 and 118. So I've run the same unit of code. I've run the exact same thing, but it's resulted in a different PID. What's happening behind the scenes is that the Erlang VM is spinning up a process. It's running that unit of code, which is just basically outputting to the REPL, and then something else is happening. So when I repaste it, it's not running on that exact same thread. It's not. There's not like, well, it's not a thread. It's a process. It's an abstract thing. Let's go back here. So I'm going to introduce another thing. I said self. Here's this this cool function I have. It's called process.alive. And what this is saying is this process actually does this process actually exist right now? So there's this weird ass way that I just invoke this function. We can invoke it in a couple different ways. We can invoke it in like the JavaScript C way. Great. There's another thing that I'm going to do now. I'm going to actually put in that pipe operator because I love the pipe operator. So I'm going to type in self, and I'm going to pipe that value into process.live. And like because this is based on Ruby, you have that stupid question mark, which I hate. But hey, we're expecting a Boolean, right? Lighthouse lads, people, you know. Same thing. So the real thing I'm trying to show off here is we can actually determine whether a process is actually alive or not from this REPL. So we're going to combine a couple different things now. What I'm going to do here is I'm going to actually spawn a process, the exact same process before, but then I'm going to pipe the return value of that into process.alive. So we've already seen before, the return value of that is actually like the process name. So I'm going to pipe that in, and so process.alive is going to tell us whether or not that thing is actually alive when I pump it in. Boom, true, great. We have an awesome situation going on. Let's try something else. Let's actually do this again, but I'm not going to actually pipe it in because the return value that's going to still be the PID. It's not going to be the Boolean value. Great, let's double check the magic. Great, PID. So let's now go look at the process. It's not alive. Because here's the next step now. When a process has done its work, when it's done its unit of work, it's dead. Previously though, when I had on line 11 there, when I was piping that into a different function, we're going to keep the process alive to let it go through its entire stack. Now, it's dead. We're finished with it. We're in a different place. This is the amazing part of Erlang. I can spin up a function like this, so I can tear that function down just as quickly. So that mental model we have of all these different processes, well, guess what? You can take a process, and within that process, you can start spinning up n other processes, and they spin up and tear down as quickly as that. It's kind of ridiculous. Or am I wrong? No, it's kind of ridiculous. Good. I'm putting that in everybody's head. So let's do some more interesting stuff with this. So I I've written this really, really small Erlang module. We've looked at it already. But what I'm doing here is I'm actually going to use some of the language primitives, or some of the APIs built into Elixir to tap into OTP. So one of those is spawn link, and the other one is receive. I'm not going to go into the signature of these functions. I'm just going to go gloss over the top part of what they do. But I'm also going to try to, within the next 4 to 5 minutes, really put the idea back in your head that you can send a bunch of different things, and you can do some really interesting stuff with it. But I first need to introduce another concept that I haven't talked about yet. And that concept is state. So who here has used Redux before? Great. So Redux is, for those of you who haven't, it's a React front-end library, and basically you're creating a new state for your entire application based off of a reducer. And a reducer is basically saying, based on a specific thing that's sent to me, I'm gonna take my state, I'm gonna create a new state from it. There's some mutation happening, and we're gonna say mutation for the sake of it, and let's not go into pedantics about JavaScript and mutation, but the main point is we're gonna create a whole new state, and we're gonna call a new action, and that's gonna be the centralized place in our application. The only reason I'm talking about that right now is just to give a good frame of reference, because this receive block kind of looks like the switch block that we have for reducers. Right? I see people nodding, so if anybody says no to that, please put their hand up, and I will definitely explain that in more detail. But that concept applies here. What we're doing is we're passing state into this function foo. Now, if you're asking me why this function is named foo, it's because the other day I was showing Tobin this entire presentation, and it was called something else. And then I said, hey, I can name this anything. The point here is the function foo can be named whatever the fuck you want to name it, because we're going to keep re-invoking it. Because the point is we're going to create a new state. And this is a functional language. It's an immutable language. So when creating a new state, it's super fast and it's super awesome, and we're not doing any crazy mutation stuff. So we're just going to create a new state, and we're going to go re-invoke foo. And if you remember earlier, when a process is done running, it kills itself. Well, foo is going to kill itself when it's done running. And in the next instance of foo is going to call itself with this new state. So going back to state, when I create a new to-do list.list, I know it's a bit verbose, but when I create this new list, I'm going to do so by calling start link. When I start that link, I'm going to create a blank list. And that blank list you can see right here. Also, slight disclaimer, when I move forward in this and it's not actually like a list, just bear with me. It's nomenclature. But this is my initial state. My initial state is an empty object. And I'm going to leave the nomenclature outside of this from now on. But this basic map here, this object, is what state is initially. After that, I can toss random things at it. So there's a part I haven't said yet, and it's a part I've been leading up to in a really dramatic fashion. But when you have all of these disparate processes, how do they talk to one another? Can anybody wager a guess? Okay, it's messages. They message pass. So I said earlier that this is like Kubernetes. Well, you're basically message passing because you have the address of every other process within your tree. So we're just going to pass these messages back and forth really quickly, and we're going to use that PID, because that's the address, and we're going to use that PID to actually do this stuff. I will say really quickly, actually, never mind. I'm just going to run the code, and then we'll go from there. First, I need to take a sip because my throat is dry. And Jordan, pay attention. Cool, so I'm going to-do list. And so said, I'm going to start link. And I'm going to assign the return value to a PID. Okay, so PID 133-ish. I say ish because it's a weird address. So if we look at this PID, yeah, great. So now we have an empty list. In our heads, let's keep an empty list. Let's actually send something to this list because we're just going to send a random message. And okay, can everybody hear me? Yes. Okay, great. Am I as loud as Leo? Nah, okay. So I'm gonna use this cool ass function called send. Crazy, I know. We're gonna send to this PID. We're gonna send it a tag tuple. Let's add a task. And that task is drink beer. Because I've clearly not had enough. Right? Like, so what returns is what I just added in. Another tuple, great. That's nicely formatted. Let's do that again. Instead of drink beer, let's bug Jordan to pay attention. He never does.
I'm glued to your presentation.
So like, at this point in time, I have a couple to-do list items. We could add like 16 more. Let's not bother. Let's actually see what this list is. So I'm going to send it another message. List. That's not it. List. But now here's something interesting. If you look at the signature of my list pattern matching, it's looking for a PID. And then after that, it's doing the send thing again, the send that I just explained, because it's going to send you a message back. Remember when I had that self? Well, here's why. Boom, magic. I honestly expect everybody to be applauding right now. I just send messages back and forth between processes that are running. But no, we can't actually see that because I'm not actually receiving properly, blah, blah, blah. So we can actually quickly get past that, and we can flush. And great, look, there's our full list. Have I bugged Jordan to pay attention? I have done that, right? So let's update that. So before I press enter, if this doesn't work, it's because
It's my fault.
it's because of Jordan's fault. Always blames the ops guy. It's actually because this isn't actually a string. Okay, so let's see what happens. I'm gonna look for my list again. I'm gonna flush again. Okay, so my problem here is actually like pebcac. Problem exists between keyboard and user.
Sorry.
But I'm gonna do this really quickly. I'm gonna kill this. I'm gonna get back in. So this comes back to the double quotes versus single quotes issue. And I've been writing way too much shitty code, so. Let's start a link again. PID equals to list dot list dot start link. So here, let's send it a message. Oops, PID. Check this out. Single quote. Okay.
Come on, man. Right here.
Sorry, my tag tuple is off. Okay, I'm gonna add a second thing of, let's probably stop drinking beer. It's probably more accurate here. So let's look at the PID. I'm gonna send it a message. I'm gonna list. I'm gonna send it myself. Right, I have to flush. Okay, great, I have all this. So now let's go back to the previous thing that I was supposed to do, which is sending to this PID. I can double check it's complete, not completed. Oops, I don't want that. It's complete. That's why I had to double check just now. Because previously I did say completed, but when I look here, it's complete. That's my other problem. So really quickly, hi Tyler. Good, I've done that. Great. I'm definitely not doing the other one yet. But let me look at my list again. Boom, say hi to Tyler is done. Like great, I just re-implemented something in 10 minutes or 15 minutes, however long I've been speaking, that we already all know how to do. Great. Fuck. Okay, let's try something else. PID 2. PID 2 is different than PID 1, I think, right? Yeah, they're two completely separate, isolated things. Let's do some to-do lists for PID 2. Masashi, what do you need to do?
I want to go home and make some dinner.
Okay, go home, Now she's got to go home, and then after that, have dinner. Oh, I can't. Oh no, so hungry.
Control C. This thing.
Syntax errors. Always plan for those. Okay, so I'm going to do two things. PID is equal to. Apparently, my computer really wants me to tell you to pay attention. So PID2. Oh wait. Send. PID2. Add. Go home. So if I send to my list PID2's list command and flush, great, we have to go home. You're not home yet. But like PID1, I just recreate it. So let's send it a message. Send PID add talk less. Definitely do that. So now if I flush, looks great. That was the last thing that really returned to my process. So let's go back to list. And now when I flush, it's down here a bit. It's sending back the contents of my one list. Let's go here. Let's look at PID2. Flush, go home, false. So what I've just showed you is that I've isolated two memory spaces. I've isolated two runtimes of two different and very, very unrelated processes. But they do the exact same thing. This is the building block of OTP. This is what allows OTP to be kind of ridiculous. And we haven't torn this down yet because we need this thing long running. And it's not going to really tear itself down. And there's a whole lot of other stuff we could do to make this way more robust. This is not supposed to be that talk. But my entire point is your mental model right now should be like, holy shit, I can't do that in JavaScript, because we can't do that in JavaScript or Ruby or Java or whatever the fuck we want to do it in. This is what Elixir brings to the world. It brings accessibility to Erlang's ridiculous runtime. And I highly implore everybody to play around with it. And there's probably a whole lot of other shit in here that you're looking at and you're like, what does that even mean? Well, go play with the language. It's super, super fun. So now let's go back to my, my final slide. Thank you. Also, announcement. We probably can go to Watson's after this. But questions? Can I start here and move backwards? Yes.
Are there like any? I know you're a big fan of this language. I remember talking to you about that. Are there any bad sides to it? You have a lot of experience.
Deployment is a pain in the ass.
Okay.
Deployment's really a pain in the ass because you have to compile for your for the OS, and that kind of changes up things. You can't have like a CI OS that's running stuff, and you can compile on there to put up onto your bare bones VM. I mean, you can definitely toss it into a container, but then within a container, you can't use the application networking. You can't use a bunch of other interesting things that come with the entire ecosystem. Really, like the big thing is the Erlang ecosystem was not built for microservices, but at the same point in time, it was built as microservices inherently. So the ways that networking works is completely different than every other conventional language. So it makes deployment a pain in the ass. People are working on it, but that's about it.
How are libraries on it? Like library support?
Amazing. Like we're talking about an older runtime than
So you can,
than the
call it
JVM.
to, like, what's the language?
You can step into Erlang. Yeah, you can step into Erlang and do tons of awesome stuff. So I'm gonna show a quick way to step into Erlang, but it's broken right now on this particular machine. Thank you, Apple. But you can do this thing. Oops. Observer dot. I think it's supervised. This might break. Okay, apparently not. So let's see. Let's do crypto. This is not me creating Bitcoin. I wish. So like here when I'm doing this, I see a whole bunch of different functions because I've stepped into Erlang standard library. And I just preface that with the actual, the colon to call the atom that exists within the actual runtime. Because we're sitting here dealing with Erlang bytecode, but we're running Elixir. So there's like a bit of a JIT compilation that's happening there, but you can jump into every single Erlang standard library, and Erlang standard library is awesome. It's just not cool to code with, unless you love Lisp. Hello.
Hello. I was paying attention.
Okay, good.
So this syntax that we saw.
Yeah.
Erlang.
No, the syntax that we saw is Elixir. Even this syntax down there, if I would continue on with this, would be Elixir syntax.
That's what I thought. Okay. Help me out here.
Yeah.
Do you also agree? It's a double question. I realize that this is an eyesore. Is there something that does the same thing but is not?
That seems highly opinionated. I've seen you code, man. I'm not sure if you're calling anything an eyesore.
Hey, it's all open source.
It's an eyesore if you're used to C-style syntax. It's the opposite of an eyesore if you're used to Ruby-style syntax. If you write only salt stack code, I don't know.
What was that list? Square brackets and inside a percent with curly braces inside? Thank you. Thank you. That's a list. Come on.
That was a list of maps. That was a list of maps.
Yeah. All right.
Sorry, you had a question. Oh.
I did, yes. So just a couple things. So the bit, is this like, so you can run as many cores as there is to the processor on the machine, or this is like an infinite amount of, like?
There's a theoretical finite upper limit. Nobody really hits it.
But is this similar to the, like, because with Node you can do the same thing, but you can also still like send messages between different processors, so you can store different things. I'm just wondering.
I don't have a good answer to that. And by good I mean like I don't have a measured factual answer to that. I have an anecdotal answer to that. My anecdotal answer was when I was at Pongal, which is over there on the other side of this wall. I built a payments platform where we were doing mass payments. I was benchmarking that. I could do 5 million concurrent payments off of not even this laptop, another laptop, an older laptop. And like these 5 million concurrent payments was basically my upper limit of how much I could run without actually seeing a big noticeable difference in the performance of my laptop. And these payments were making, I was basically spawning off a whole different process per payment to make a call to Visa. So each one of these things was handled in its own particular process. Each one of these particular processes would handle all the different error states and all the different parts, all the different parts of the process that you needed to do to actually make a transaction. So that those parts were like, figure out what that transaction actually looks like, log that transaction to the database, make a call, log the response, return to the client, and a bunch of other stuff. And I was doing that like at a ridiculous amount. Like 5 million is a fucking absurd number. In Node, I was doing the same thing at like 1,000 a second. I didn't even try it out in any other language, but I started off in Node to just try this out, and I went up to 5 million because the concurrency is just ridiculous and just send stuff off, and it can actually add asynchronous stuff, actually add asynchronous execution to it. What do you want?
What I want to do is actually help you, because for any people that know about systems engineering or operating systems, these are not actually processes.
These are not OS processes. Exactly. It's a different concept, it's a different nomenclature. It's just an abstraction of a term that existed a long time ago. It's a very small thing. It's not tied to an OS thread in a specific formula, but there is a finite limit. We just don't know what that finite limit is at a digestible manner because it's different on every system because it's environmental. Right? Like your heap plays into it heavily as to what you're actually doing. So there's always something that holds it, but there's a million different things you can do to mitigate any issues that come up with it. So in the Erlang ecosystem, I'm sure somebody knows, but I don't. Any other questions? Sasha, any questions?
Not actually, I was about to ask, because when I took up the PSAX, the list of all the process, I only one process in Elixir. So probably inside of it, all these Elixir unique processes managed in the whole other world.
Yeah, and I mean, I would show off all the different processes, but my MacBook, my new MacBook has decided not to work well with me, and I couldn't really show that off. But maybe the next Polyhack talk I do, I'll move into Gen server, which is like a generic server, which is an abstraction over what I just showed, and we'll talk about supervisors. But otherwise, let's yes.
Can I do one more?
One more. Go
All
ahead.
right. What is the? Have you measured the overhead of all this context switching between these bajillion different processes?
No.
Okay. Is it a lot? Do you think?
I don't think it is.
No.
Like,
Pretty quick.
yeah, I've never felt the need to. It has never been a bottleneck to me. There's a lot, there's a lot of different strategies. Like the way that I'm showing using spawns and all that, and using like the receive and do, that's not how I would write a real world application. I can't show you a real world application, but that's not how I would write a real world application. There's a lot of other things built in that you can actually pull out of Elixir standard libraries that wrap up Erlang standard or Erlang non-standard libraries that are basically standard libraries. There's a lot of interesting things you can do, because again, like this thing is like 30 years old. There's a lot of thought put into this. The people who use it are extremely intelligent, way, 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 way smarter than me. That's why I'm badly articulating how good the runtime this is. But try it out, really try it out.
That's very cool. I like it.
Anybody else? Okay, cool. Thank you.